All right, so in this video, we're going to be looking at how to calculate the distance between a point and a plane in 3 dimensions. So we have a point in space. This is the point P. In this example, 3, -1, 4. And we have a plane that's provided to us, 2x plus 5y minus 3z equals 11. Now, we're going to need, for our equation, we're going to need first the normal vector to the plane. Now, the normal vector to the plane, when your equation is in this standard form, is very easy to find. It's just going to be the vector pulled off of the coefficients, like so. So this is going to be our vector. And the other thing that we're missing is a point on the plane. Now, we can pick any point we want on the plane. It doesn't have to be any particular point. So probably the easiest way to do this is to come up with a set of x, y, and z values that will either be equal to 11 or sometimes it's easiest to just pick 0 for 2 of the variables. In this case, that's not going to work, but I'm going to say Q will be the point 0, 1, -2. And let's just double check. If I put that in, that gives me 0, that gives me 5, -2 times -3 is 6. 5 and 6 is 11. That is a point on the plane, so it satisfies our equation. So now what I need to find is find the vector PQ. Now, remember that the vector PQ is basically just the difference between Q and P, so subtract. So in this case, we're going to get 0 minus 3, because we have to do Q first, because we're going from P to Q, so Q is the endpoint. So 0 minus 3 is going to be -3, and then 1 minus a -1 is going to be 2, and then -2 minus 4 is going to be -6. So that's our PQ vector. And then for our formula, we're going to need essentially to dot either PQ with the unit normal vector, so we can normalize this, or we can just dot PQ and the normal vector and then just divide by the magnitude of the normal vector. So our distance is going to be, so let's do the dotting. The numerator is going to be 2 and -3 is going to be -6. And then 5 and 2 is going to be 10. And then -3 and -6 is going to give me +18. And then I'm going to divide that by the magnitude of my normal vector. So 2 times 2, 2 squared is 4. 5 squared is 25. And -3 squared is 9. And so my numerator is going to give me 22 divided by the square root of 29, and then 9 more is 38. Now it's very normal. I don't think I've actually ever seen a problem where you get a nice integer or even a rational number. You almost always have square roots in these problems, and that's just the way that it is.